Hello everyone, welcome to the fifth lesson on finding smart ways to solve questions. Now in this lesson what I'm going to do is I'm going to take a few sample questions to show you how you can solve a question smartly even if you don't know the right methodology to solve it. Now this video is in no way advocating these methods, but these are just some last minute attempts to solve a question if you have no clue how to go about solving it methodically. Okay, so in short, what I'm trying to say here is that there are certain questions which can be solved by taking numbers, okay? And it's a good thing to at least be able to identify those questions, so that if in the worst case scenario, if you don't know how to approach the question using the conceptual knowledge, then at least we can take numbers and solve the question quickly and get the answer. Okay, but don't substitute number taking as a primary method for the conceptual method of solving question, please. So I'm going to take two questions and I'm going to solve both the questions first using methodical way and showing you if your conceptual knowledge is good, then also you can solve the question within 2 minutes. Okay, and after that what I'm going to do is I'm going to take numbers and show you that even if you don't know anything, we can still take numbers and solve the question within 2 minutes. So here's the first question. You can pause the video, try it out, and then you can resume to see how we can solve it. Okay. So I'll start off by showing you how to solve this question in a methodical manner. And this question, it's given that p is a positive integer. So p can be 1, 2, 3, 4, so on and so forth. Okay, it's an integer. And an expression is given to us, which is 5 plus 1, 5p plus 3, and 5p plus 2. Okay. And we're asked the remainder when this expression is divided by 6. Okay. So we need to just find the remainder when this is divided by 6. So we have written down what is given to us and what we need to find out. Now we should try and define the methodology. So what should be the right approach to solve the question? Well, the first thing that you should be able to infer is that if p is a positive integer, then that means 5p plus 1, 5p plus 3, 5p plus 2, all these terms will be integers, right? And since all these terms are integers, one way to go about it is to try and plot it on a number line and see where do these numbers lie. Okay, so we need to focus on the nature of the number after understanding that these are all integers. And since we're dividing it by 6, it has to do with something with even, odd, or the divisibility of 2 and divisibility of 3. That is another way of thinking and going in that direction. Now, if I plot these three numbers on the line, then I'll get 5p plus 1, 5p plus 2, and 5p plus 3. And after looking at this, can you think what kind of numbers are these? They're integers, keeping this in mind. Now notice they are integers and they are 5p plus 1 plus 2 plus 3. That means these three numbers are consecutive integers. Okay, and since they are consecutive integers, they could take values such as 6, 7, 8, 10, 11, 12, 16, 17, 18. Again, these are some sample examples. I'm no way telling you that in a methodical approach you need to take values. Once you understand that these are consecutive integers, and if your conceptual knowledge is really good, then you should be able to infer that three consecutive integers, the product of any three consecutive numbers or integers, is divisible by 6. It's always divisible by 6. So if it is completely divisible by 6, and that means the remainder in this case will be 0, and the answer will be option A. So see, if you're solving methodically, you can still get the answer, and it hardly took me a minute and a half to solve this. I just had to identify the fact that these three numbers are consecutive in nature, and GMAT does test you on this a lot. So whenever you see a plus 1, minus 1, plus 3 in terms of variable, and they're asking you the remainder, do try and see if you can plot that on a number line and see where they are placed, or try and see the even odd nature. Even that helps sometimes. Okay, now, but let's say you could not figure anything and you wrote down the information and you're not sure what to do with these variables, and that's absolutely fine. But see, you need to find out the remainder, right? So you should ask yourself, can we take some numbers and solve the question? Can we take the values of p as 1, 2, 3 and solve it? Will we get different remainders? Well, if you would have got different remainders, when you're putting different values of p, then in that case, in the question stem, they would have specified what p is. That is one. Or in the answer options that you have, okay, these 5 answer options, one of the option would have been cannot be determined. Because if you are getting different values, different answers for different values of p, then obviously you won't be able to find out the answer. So one of the options would have been CBD, cannot be determined, but it's not here. That means you should be able to infer that whatever be the value of p, we'll always get the same remainder, and the remainder has to be one of the 5 values that are given in the answer options. Okay, so this is a very important inference that you should be able to make. That's a smart way of coming with a conclusion. I'm not using any conceptual knowledge. I'm using something which is called logic. I'm trying to find out the remainder. I have a concern that different p's might give me different answers, but the answer option does not have cannot be determined. That means this should work for any value of p. And once you're able to make that inference, just take any value. So for example, you could take p is equal to 1 and just solve and find out what the remainder is, and that will be your answer. So if I put p is equal to 1 here, I'll get 5 times 1 plus 1, 5 times 1 plus 3, 5 times 1 plus 2, and that is 6 times 8 times 7. And you can clearly see that 6 times 8 times 7 when divided is completely divisible by 6, and that means the remainder has to be 0. So I hope this is perfectly clear how to solve questions taking values. Number of times you'll be given these kind of expressions in topics like divisibility and topics like algebra, and in these places it makes sense to take values. First of all, logically figure out whether taking values makes sense or not. See, I did not start by just randomly putting values. That's very important. That is why the lesson name is Finding Smart Ways. You have to be sure that you can find value, you can take values to solve the question, and then only you take it and solve. Okay, let's take another question to solidify this learning. Now here's another question on which is based on algebra, and here you can clearly see that you've been given an expression which looks scary, right? X squared y cube x y to the power 4, so on and so forth, and you need to find out this expression is equal to which of the following 5 options. So how should you solve it? Well, as I told you, I'll show both the methods. Let's look at the methodical way first. We'll first of all jot down what is given to us. We are first told that x square y plus y square x is not equal to 0. That means the denominator is not equal to 0. Okay, and then we obviously have this expression and we need to find out it is equal to which of the following. But as you can see, this might turn out to be a Herculean task. You look at this expression and you might be scared and you might wonder, hey, what should I do? Well, if you're worried about the right approach and if you want to solve it in the methodical manner, the only option that you have is try to simplify the expression. And you might say, hey, it's very easy for you to say simplified, but how? Well, you need to look for patterns. One thing which is very clear is that both the numerator and the denominator has x and y, and they have ample amount of x and y. So you should see whether you can take out some x and y common from the numerator as well as the denominator, which you can cancel and simplify the expression. Okay. Now look, in the numerator you have x square, x cube and x to the power 4. That means the maximum x that you can take out common is x. Similarly, in case of y cube, y to the power 4, y square, y, you can take out y common. So you can, in short, take out x into y common from the numerator. From the denominator also you can take out x into y common. As you can see, x square x, so the max that you can take out common is x. Same goes for y. And on doing so, you will be able to write the expression like this. And then you can cancel out xy. Okay, so now you are left with this particular expression. Now notice in the denominator you have x plus y. Okay, and in the numerator you have still 4 expressions. So now your job should be to see, is there any way in which I can get x plus y in the numerator also, so that I can cancel them? Okay, that is how your thought process should be. And another way to understand it is by looking at the answer option. See, in the answer option that you had here, there's nothing in the denominator, which clearly means that the denominator has to be cancelled with something in the numerator. So see, I'm again thinking very logically that I'll somehow get x plus y in the numerator. I've come up with the conclusion by looking at the answer options. So now what I can do is I can take y square common from this, because I need x plus y, so I just need 1y. So if I take y square common from here, I'll get x plus y, and from x square y plus x cube y, if I take x square common, I'll get x plus y. So now you can clearly see that you have x plus y in the numerator also, and you can write this given expression like this. And once you write it like this, you can cancel out x plus y and you'll get x square plus y square. And you can say that the correct answer in this case is option C. So I hope this is perfectly clear how to solve the question methodically. But again, the agenda of this lesson is to tell you how to find a smarter way to do this, because I see a lot of students do struggle when they see a lot of variables and they're not sure that they will be able to take out common and solve the question, especially this step where I'm taking y square and x square common. This is a tricky step. A lot of you might falter here. So in this case, let's see how we can solve this question in a smart way. Okay, if nothing clicks and you're still wondering what to do, then you need to ask yourself, okay, can I take values and solve the question? I have these options with me, and I can see there are only two variables, right? So if they have two variables and you know this expression will somehow translate the given expression into this, then you should reason out and be able to infer that, okay, yes, I can take values. What can I do is I can take, say, value x as 1, y as 1, or x as 1, y as 2, and see what value I'm getting for this expression, this full expression. And I will place whatever answer that I get. Once I place that value here of x and y, I should get the same answer in one of the options also. Now, if this sounds complicated, let me just show it to you. What you can do is you take this expression and you decide some easy value of x and y, and always take values which are easy to simplify. So what I prefer is, if there's no constraint given here, what I would prefer is to just take x1, y1. That's the easiest value that you can take. And I place x1, y1 in the expression. So 1 square, 1 cube, 1 times 1 to the power 4, and so on and so forth. Okay, on doing so, you'll notice that in the numerator you'll get 4 ones, and the denominator you'll get 2 ones, which is 4 by 2, which is ultimately equal to 2. Which clearly tells you that if x is 1, y is 1, the value of this expression is 2. Now, when I place x1 and y1 in the answer option, so first answer option was x minus y, I'll see in which case will I get 2. In the case where I get 2, that has to be my answer. So in the first case, if I put x1, y1, I get 0, and 0 and 2 are not equal. Now I'll go to option 2. Option 2 is x plus y. I'll put 1, I get 2. Now I can think that this can be my answer, and some of you might in a hurry mark this as answer, but please don't do that. Make sure that this is the unique answer and there's no other answer option that gives you the same answer. Because unfortunately, when you go to option C and you put 1, 1, you'll notice that even this gives you 2. Okay, so this can also be your answer. Now when you take D, it's a big expression. When you put 1, 1, you'll get 3. Okay, so this cannot be your answer, and obviously E1 times 1 is 1. So A, D, and E are not your answers. So notice, after putting 1, 1, you're able to zero down to 2 options. So you know your answer has to be either B or C. So all you need to do is take another value and solve it. Now I know when I'm explaining it sounds like a big task, but this is how you need to reason out yourself. While you read the question, you see that you don't have any clue to solve the question. You ask yourself whether you can take values to solve it or not. You say, yes, I can. And then you put the first value, 1, 1 is very easy to solve. You put in the answer options and you see, okay, 3 of them are eliminated, 2 of them are left. Now in this case, what you can do is that you take another value, and that value, say for example, again has to be an easy one. So you can take 1 minus 1, or you can take minus 1 minus 1. So I'm taking minus 1 minus 1. Okay. Now you might ask, how did you decide minus 1 minus 1? Well, I did that by looking at x square, x square. So I know these squares will give me values as positive. So let me take a negative value. Let me take minus 1 minus 1 and see what happens. Because if there's anything tricky going on or related to positive negative values, I should be able to eliminate either B or C in that case. Because if the answer comes out to be negative, I know my answer will be B. If everything turns out to be positive, then I know my answer has to be C. So I need to take that call during the exam time and solve the question. Again, with sufficient practice, believe me, all this becomes really intuitive. So you take minus 1 minus 1, you place minus 1 in the expression. Again, the expression looks slightly big, but you can do it mentally also. So if you put minus 1, 1 square, x square would give you positive value, y cube would be minus 1. Here x would be minus 1, y to the power 4 will be positive. Here x cube will be negative, y square will be positive, and so on and so forth. And once you solve it, you'll get something like this. So notice here in the numerator you're getting minus 4, denominator you're getting minus 2, the negative gets cancelled out and you're getting 2. Okay, Now, when you took -1, you're getting 2. So that means if I put it in option B, I know that cannot be my answer because I need 2 and I'm getting -2. So obviously, the correct answer has to be option C. So I hope it's perfectly clear that it's important to first of all understand what kind of values you need to take. I have seen students take random values to solve the question and then realize that, hey, taking numbers does not always work, or I'm not really good at it. That's not the case. Sometimes taking numbers may help you solve the question quickly, but even there you need to apply a bit of logic to decide which numbers to take. So here's the final takeaway. Keep in mind that this is not a substitute for the methodical way to solve the question. If possible, make sure that your conceptual knowledge is so good that you don't have to resort to these methods. Worst case scenario, if there comes a scenario that you have to apply these methods of taking value to solve the question, okay, make sure that you're smart enough to decide what numbers to take to solve the question. Okay, and these are some of the questions where you can take numbers to solve it. Keep in mind, you cannot apply this in all questions. And lesson 6 is exactly about that, where I'm going to talk about where you should take numbers and where you cannot. In this lesson, I just showed you if you are not able to solve methodically, take numbers, but you won't be able to do it in every case. And if you like this lesson, do make sure that you see the next lesson tomorrow, where I'm going to talk about where it's not possible or it's not advisable to take numbers to solve the question. Okay, now I'm going to give you 2 questions on this. Try it out. I'm very sure that you will be able to solve them correctly. All the best, guys.